Welcome everybody to the workshop. We'll just give it a few minutes for others to join. And I just, first of all, welcome to the workshop. This is Vernier's virtual workshop on Enzyme Action. I'm here with my colleagues John and Sarah, who will be helping out during the workshop today. So you should have access to the chat, and I just shared a shared Google folder that has the handouts for today's presentation. If you didn't have a chance to download them prior to now, you can find them there. I also wanted to let you know that we will be answering questions throughout the training today, and there'll be time set aside at the end dedicated to questions as well. And we ask that you use the Q&A feature on the menu bar that comes up instead of the chat feature, and we'll be monitoring the questions. Sarah's in the background, so you'll hear her voice come up and deal with questions with John. Just as a follow-up, if we don't get a chance to get to your question today, we're going to do our best to try to answer them all. But if we happen to not get to your question, we will follow up with you afterwards. And just to let everybody know that this webinar is being recorded and will be available on our website after today. So I'd like to introduce you to your main presenter, John.
Hello. I'm John Melville from Vernier Software and Technology, and today we're going to be talking about enzyme action and enzymes and different ways to look at enzymes. And what I'll be doing is I'll be showing you how to actually do this lab. I'll be giving you some hints on how I would approach doing this lab. And then I'll also go through our remote learning resources and then two other things that you can use for remote learning. And then the other thing that I was going to ask, or what I will talk about, is I assume probably some of you teach AP. So I'll go through different AP ways to look at this lab and even the inquiry version. But the first thing that I wanted to talk about is I'm going to just share my screen so you can see my setup and not just look at me talking. So I'm going to do that right now. So hopefully now you should be able to see my desktop, and what you should see is Graphical Analysis. I've launched over here on the left. I have a video of what I'm going to be doing over here on the right, and then I've got our Vernier website down here down below. So what I wanted to do first though is just talk about enzymes. Enzymes, I'm a former college instructor, and I used to train biology teachers when I was at Wartburg College. In addition to just teaching research methods, and enzymes are just critical. And they're one of those things that's really simple to show in the classroom in a number of ways. The classic way that a lot of people look at the enzymes is by using catalase. And catalase breaks down hydrogen peroxide into water and oxygen. Now, the two traditional ways that you can look at this enzyme activity is by either using a gas pressure sensor, because the oxygen that's liberated is a gas, and then you can look at gas pressure. But I prefer using the oxygen gas sensor. And the reason why I prefer using the oxygen gas sensor is because then I can just explain to students, look, I'm really seeing oxygen gas. I don't have to explain that extra step, especially to biology students, that the oxygen gas that's liberated forms a pressure head, and then we can measure the pressure head. We can measure the oxygen directly. And one of the cool things, so I'm gonna wind up turning off my video for a little bit, because I'm gonna wind up going and showing you things over here, if you could see that. So I'm gonna be doing stuff over here, and I'm gonna be showing you how I've prepped, and we're gonna actually do this first experiment. But I wanted to show you just a few things about the oxygen gas sensor. So let me turn my video off. And if you have any questions, I can still get them in chat and stuff like that. But I just wanted to show you the oxygen gas sensor. I'm going to be using the new go direct oxygen gas sensor. And I actually already have it connected. That's why it's blinking green. A lot of people refer to our new go direct oxygen gas sensors as wireless, which is true. But they also have a USB port. And the simplest way to get them to work is just to plug them into the USB port. And what's also really nice about most of our gas sensors is they fit right into the Nalgene bottle that they're supplied with. So the whole reaction is going to be taking place in this bottle. So any questions so far? I mean, I'm just going to take you through the basic setup. Let me turn my video back on here really quick. So
we don't have any, there's no questions in chat just yet.
Okay, great. One thing that I wanted to talk about is what to use as an enzyme source. The other reason why I brought this up as why I think it's a great activity to do is this is something that you could easily do at home or in your office like I am right now at home with your students on a Zoom call. You could do the entire experiment like I am. You could show it to them. They could see it really happening. It's also so simple because all that you need is water, hydrogen peroxide, which you can buy at any store, 3% hydrogen peroxide. And you can use yeast as an enzyme source that students could actually do it themselves if they had the equipment. And then I have these test tubes over here, but I'm going to show you that I like using 15 mil conical tubes just because I can measure everything out better. But I'll show you how to prep it. And then also the other thing that I would recommend is I like to also use Purified Catalase. Now you can buy Purified Catalase from Flynn Scientific. The reason why I like using Purified Catalase as opposed to yeast is because I know that the reaction, if I'm using purified lyophilized enzyme, I can mix it up in water and it's going to be the same every single time. So the number of drops that's used, the concentration that's used, it's all going to be, the response is all going to be exactly the same. If you're using yeast as an enzyme source, you have to be really careful about the yeast grow over time. The density of the number of cells that's there is going to be problematic. And that's actually why I have the yeast. I'll show you that over here. Let me move this out of the way really quick. You can see over in the far corner, over here, I have yeast on a stir station. So I'm spinning that yeast to make sure that all of the cells are suspended. The way that you would get around that if you were doing it in the classroom is you would just put that in a test tube and just invert it a few times before you had the students take a sample of it. All right, so let's go back and do the actual experiment. Hold on, I'm gonna turn off my video. So what I've done here is I've launched Graphical Analysis. I've already set up my data collection parameters. So I'm going to collect for 180 seconds. I've got the oxygen sensor already set up and I'm ready to just hit the collect button. And what I'm going to do is just follow the actual instructions that in the preparation. And those are actually in the document that Angie shared with you. Oh, no, that's the wrong one. So you can see all that I'm going to do in this case. I'm just going to do the first step. What I'm going to do is I placed the 3 test tubes in the rack and I've labeled them 1, 2, and 3. And I'm just going to do one first. I'm going to fill one with 5 mils of 3% hydrogen peroxide, 5 mils of water. And then what I'm going to do is I'm going to add 5 drops of enzyme to test tube 1. I'm going to invert it a couple times, put it in the Nalgene bottle, pop the oxygen gas sensor in there and hit collect. And then once we've done that, I'll show you the next method. So let's move over here back to the test tubes. So I'm going to do so here's my water. going to use 5 mils of water. There we go, 5 mils of water. And then 5 mils of my substrate, which in this case is just 3% hydrogen peroxide. So there's where I'm going to be doing the reaction. I'm going to be mixing it up here. I'm going to be putting it in here. And then here's the sensor that I'm going to use. So I'm going to use 5 drops of yeast. So I've just pulled up some yeast, and here we go. 1, 2, 3, 4, 5. Then I'm going to invert it, invert it. And then I'm going to hit collect. And then we'll wait to see what happens here with the oxygen gas. And one of the things that you can do in GA that'll help, this is a biology trick that I've done for years, is, you know, in the first case in a lot of our experiments, we're looking at the smallest response first, right? So 5 drops of enzyme is not going to be as big as 10 drops or 15 drops. So if you hit the auto scale button down here, there, now you can see that I do see a response. And that's just one of these tricks that I've learned over the years in doing these experiments is, for those of us biologists, we almost always do our negative control first. It can be really helpful to actually use that zoom in button first so that students see a response happening right away. So while we're waiting for this reaction to happen, do you have any questions? Has everybody done this lab before, done it in this way, or done a version of it?
Not seeing any questions yet, John.
Okay, thanks.
Just as a reminder, if you have any questions, go ahead and put them into the Q&A.
Oh, so there, it took off a bit. Let's see the bubble.
John, we do have a question that came in that asks, why did oxygen drop the first 10 seconds?
Oh, the oxygen is going to drop the first 10 seconds. We'll probably drop the first 10 seconds because I'm popping the oxygen gas sensor into the bottle and there's a little pressure head. And if you were to wait a little bit longer, you probably wouldn't have seen that. So, but that's why. And effectively what we wind up doing is looking at the initial rate at the end, which is critical. You can see it's beginning to take off right now. And that was something else that I wanted to, I'll show you or talk to you about. You can actually see, if I were to zoom up here, let me see if I can zoom in and you can see this.
John, we also had a request to see if you could move. Oh, perfect. Look at that.
Yeah, so I was going to show you that you can actually see the bubbles forming. And those are the oxygen gas bubbles that are forming. And that was something else that I wanted to bring up that's interesting in this case. I'm going to zoom back out. Is if you're doing this lab in the way that it's written, you really don't want to move the bottle once you've started the reaction, because the number of bubbles that are being liberated is going to be dependent on movement. That's why actually in the instructions it actually says using a stir station is optional. And I was going to repeat this again with a stir station just so you can see the difference when you are actively moving them. Do we have other questions in chat or anything?
Not yet.
Okay, great. So, you know, I could come along and I could actually look at the rate that this occurred at. I could do apply curve fit. And then that would be my rate right there. The slope, 0.01704. And I could do the same experiment again, looking at more drops. So why don't I do that? Let's just look at 10 drops. So I'm just gonna rinse out this bottle, let the oxygen gas sensor come back down to what it needs to be. I'll pour this out. While we're waiting for the oxygen gas sensor to come back down to where it was at the beginning, I'll just put some more substrate. Actually, I'll do water first. 5 mils of water. Five mils of substrate. All right, so there we go. I think our oxygen gas sensor, it's close. Yeah, it's close to where it was at the beginning. It's around, it's below 20. So what I'm going to do next is I'm going to put in 10 drops. Swish it around a little bit. Then, all right, I'll hit collect and let's collect the second run. And I can overlay both data sets. Let's see. Oh, there you go. It's already way faster. Questions? Let's see if there's a chat. Can you start the oxygen gas sensor before putting it in the bottle? You can, and actually I used to do that all the time because it's a good marker. You'll see a big pop that happens, not a pop, but you'll see a change. So it's a good marker for the students to see when they actually put the oxygen gas sensor in the bottle. The only issue that could be a problem is you don't want to see a big event happen that swamps the actual data that you're interested in. And you can see once again here, in this case, right at around 70, there's a dramatic increase in the response. There we go. So what I was thinking I was going to do next, what I would do next is I was going to do the version of this activity that uses the inquiry lab preparation, which is slightly different. In our inquiry biology book, what we do is we put it on a stir station. We use 10 mils. And then we actually use, I'm going to use an enzyme suspension of catalase that I've made. And you'll see that you would see that the response is going to be much cleaner as it starts off. But you could see in this case, if you grab the response from the last 100 seconds and compared those two slopes, they're going to be very different. And what's really great about this activity in the first one, when you're looking at the effect of enzyme concentration, increasing the rate should increase proportionally as enzyme concentration increases. And we can take a look at that here and see if it's close. So let's take a look here at the slope in this case, in these two cases. The slope is 0.1 to 0.2, and you can see that in this it's 0 or 0.2, 0.3. You know, I'd like it a little bit better if that was closer to, well, that's actually close. That's actually really close. The yellow slope should be twice what the blue slope is. And it's 0.175. If that was 0.15 and this was 0.3, then it would be almost perfect. That's really good for just having, you know, an eyedropper with some yeast suspension and not a lot of control over delivery. That's actually pretty nice. So I take that back. That data looks pretty good. Other questions so far? I know that a lot of you are working remotely or probably working remotely, but I just wanted to show you that you can do this lab in this quick period of time that I've done with your students and show it to them. I want to take the next 5 minutes to actually demonstrate another method that we use to look at this activity using the stir station, just so you can compare.
We did have a question, John, on why was there an increase at 70 seconds?
Exactly. That's what I wanted to, that's what I'm going to get at. Thank you. Thank you for that. It's related to the fact in that both of these cases at 75 here, that since the oxygen gas is being liberated, the data looks way better if you have it on a stir station. Why don't I just do one more run? I'll do 10 drops, but I'll put it on a stir station. We'll do everything exactly the same, and you can compare the rate to see how that looks. So let's do that really quick. I'm gonna put this over here. I have a stir station in this case. So the reaction is going to take place over here. So once again, let's take 5 mils of water. Sorry, my bad. Five mils of water. Five mils of substrate. I will then add 10 drops. I'll let that equilibrate for a minute. Not a minute, but a few seconds, and then I'll hit the collect button. And what I'm doing in this case is I've put in something that's agitating the sample so that it's going to make sure that the oxygen is liberated at a much more constant rate. It really helps give you clearer data or cleaner data. The other thing that helps give much cleaner data is actually using an enzyme suspension, which I have here. So this is Purified Catalase over here that I've gotten a suspension. In that case, when you deliver it or you put it into the sample, you know that you're getting the same amount each time. But we'll just see how this data takes, how it looks here. You can already see that it looks quite a bit cleaner, I would assume, if you, so far. Let's see what happens at 70 seconds. So this is why I would say, like, for AP biology, or if you're teaching college, I really recommend using the stir station, because the data is going to be, it should be much cleaner and a lot more comparable between runs. The other thing that I recommend, if you can afford it or if you have it, is these work great. A pipetter, as opposed to putting in 10 drops, you can assume that 10 microliters is a drop. And if you deliver like 100 microliters, 50 microliters, 100 microliters, and 200 microliters of either yeast suspension or enzyme suspension, you're delivering the same amount straight away. And part of the issue here is that the reaction is quite fast. And if the time that you're taking to put those drops in, it takes longer for the reaction to happen. So I'm already happier with this data, the way that it looks. And that's, I mean, I did everything exactly the same. The only thing that I've done is put it on a stir station. And I know that everybody can't afford a stir station, but that's why we have put in the instructions that the stir station is optional. Other questions?
Nothing currently.
All right.
Were you going to show them the catalase, the other option for catalase?
The other option, you mean the one for the BioI option? I could, or I was thinking I could also switch to showing them the remote learning resources and things like that, since we have 15 minutes. I mean, the real thing that you need to be aware of if you're going to be doing the inquiry version is all that we do is that the setup is exactly the same that you see over there. It's a stir station, but we use 10 mils of enzyme suspension instead of 5. We use 10 mils of hydrogen peroxide, and then you use a pipetter, and you just put in 50, 100, you deliver it a lot, you deliver it all at once instead of using drops. That's the big difference between them. The other thing that I wanted to let you know is, well, we'll talk about that here in a minute, but I think everybody can see that that data is much cleaner. But remember, it is the same. Like if I were to come over here in the last 100 seconds, and if I were to look at the slope, these slopes are pretty close to each other. 0.031, yeah, really close, 0.03. So there's nothing wrong with the data. It's just you would need to make sure you grab the slope over like that last 100 seconds there. You know, whereas the data is much cleaner if you're using a stir station. Other questions? All right, then I'm gonna stop showing you my video here. I'm gonna break down the setup here unless you have other questions. The reason why I'm putting the oxygen probe straight up and down is because it's got a gel inside of it, and you need to just remember to do that, to store it standing straight up and down. All right, so let's stop here for a minute, and then I'll get rid of this data. We'll come back to this. I'll just do File New. Oh, let's close it. I'll come back here. So I assume that many of you, and I'm gonna turn my video back on so you can see me talking. I hope that's okay. So that was basically a hands-on demonstration on how to do that activity with some tips. If you have any questions or want to get in touch with me on how to do that lab, you can always email me at biology@vernier.com. But a lot of this sample data that I already showed you lives on our website and is free for you to use. So if you were to go to our website over here, you should see my screen. And if you were to go to Explore Remote Solutions, so I'm at the Vernier website, and if you were to go to Explore Remote Solutions, and then tap on high school or college, if you tap on either one, it's going to take you to these different options. And the one that I want to focus on is the free data. So analyze experiment data at home. So if I click there and go to Analyze Free Library, there is an entire library of sample data and instructions. And this is actually part of what Angie put into that Google folder that you have, and we'll go back there in a minute. We can take a look at that folder. But if you browse the library here, you'll be able to see that we have all of this data here. In Biology with Vernier, we have the lab write-ups and the data, what could be used, along with some videos that you could use. In Biology with Vernier, I have been doing Enzyme Action right here. That lab, there's a video that shows how to do it, what software is required, but all of this is sample data that's free for you to use and with your students. And actually that's what Angie has put in here in the Google Drive that you should have access to, is all of these different sets of data. So this is just the sample data that's already on the website. So let's go ahead and take a look at that and see how to use it. So I'm going to launch Graphical Analysis. I'm going to launch it. And then I'm going to double click on one of these labs. Let's see, I'm going to download it. And then I'll launch it and it'll come across. There we go. So here is the sample data that I collected using that same preparation that we just talked about. So when COVID first started happening, we all went home, we all collected data because we knew that teachers would need sample data to use at home if you were going to be working remotely with students. So you can see in this case, I've got 5 drops, 10 drops, and 20 drops. This was all done right here, right actually where you see me doing that experiment. That's all where it was collected. And these are 3 runs. And if we take a look here, like the last 80 seconds, and you can probably guess that I was using a stir station because look at how pretty and nice that data looks. And if I go to apply curve fit, you can see that this one has a slope. What's the smallest one? 5 drops has a slope of 0.4. You know, twice of that would be 8. It's close, it's 0.010, so it's a little higher, and then twice of that, 10 times 2 would be 20. For 20 drops, here we go, that's close. And we have this for like all sets of data. So in addition to having this for this part of the lab, the second part of the lab looks at temperature. So let me download that and we'll take a look at it. Oops, hold on here. I don't want that. I'm just going to launch this into Graphical Analysis. Hold on here for 1 minute while I load up the data.
John just did a perfect demonstration of what can happen if you just double click on a file to try to open it rather than launching the app and then browsing to the file that you would like.
Yeah.
So if that ever happens to you, just go back, open the app first, and then just open the file from within the Graphical app, and that should avoid that problem.
Yeah, let me show you how to do that actually. The best thing to do, there we go, here it is. So here's the temperature data. And the second part of this lab, what the students are told to do is look at the reaction at a given temperature. And so in this case, this is all at 20 degrees C. This is all done at room temperature. And then they look at the average, right? So you could then find out what the average is. But I also know or knew that you would probably want to be looking at more than just that. So this other run that you have access to in the sample data, let me go back there. Hold on. Let me find out where that was in the chat. Hold on. There we go. So if you take a look at here, part 2 is actually all of the temperature data. So I went and did all of the runs at all the different temperatures. I didn't do 3 of each one, but I got 1 of each one so that you could use that. And we even have part 3 here, which is where I looked at the effective pH. So, and like I said, all of this is free. You can use this with your students. You can download it. You can share it with your students. You can give it to them whenever you want. Now, one of the things that I have access to as well is when I was working on the inquiry biology book, I have access to a lot of inquiry data sets as well that are related to this lab. So I have like looking at different effects of temperature, or looking at different pHs, or looking at substrate concentration. One of the things that we also did that I wanted to put in here is we have a really cool caliper activity where we realized a long time ago that one of the problems with this lab, if you're looking at the effective temperature, is if you are heating up the sample as you are measuring it, you have 2 confounding factors. You have the temperature increasing the degradation of hydrogen peroxide, and you don't know what the effective temperature is on the actual enzyme. So we wrote up a different lab activity that is actually a caliper article that I've put here. That is what we call the temperature of denaturation. So in this case, in the experiment, what we did is we took the enzyme sample, we put it at a temperature, heated it up to that temperature, then cooled it back down to room temperature, and then only did the experiment at room temperature. So you can then see when the enzyme begins to be denatured. So we have all of that data available for you here. And I actually have the lab write-up as well, in case you want to take a look at that. That's here. I also have put in here all of the inquiry data sets that I had access to. These are things that I released that I have access to. They have not been released, but if you want to take a look at them, you can. Now, they're in LoggerPro files, but if you want to convert them to GA files, there's a really great way to do that via data sharing that I could show you how to do. Just get in touch with one of us and we'll show you how to do that. But so these are different data sets that you can look at, take a look at, and use if you wanted to. Other questions? I know that's probably a lot of information, but I wanted to give this to you here. And then in the last little time that we had left, I wanted to show you 2 different options that are another version of remote learning. I don't know how many of you are familiar with Pivot Interactives, but Pivot Interactives is a website where you can log in and they have different activities that you can do actually with your students. So this is an actual video of an enzyme reaction. It's very similar. It's the same catalase reaction. And there's an introductory activity, but then what's really interesting as well is they can actually, oh, hold on, someone had a question. Does graphical analysis work on Chromebooks? Yes, graphical analysis works on Chromebooks, it works on iOS, it works on Android, it works on everything. So that's what I was saying is if those LoggerPro data sets, there's a real simple way to move them into graphical analysis so your students could use them on whatever platform you want. But graphical analysis works on any platform. The GoDirect sensors as well that we were just using also work on any platform because they have a USB port and they have Bluetooth. So they'll work on anything. Well, almost anything. But if you wanted to use Pivot Interactives, what you can do is you can actually measure in this case, the amount of oxygen that's evolved while looking at different pHs. And in this case, the video is what the students interact with. And there are several different experiments here. So you can look at the effective temperature or the effective pH. You could also look at the effective pH at different temperatures. So there are, here at 0 to 3 degrees C, there are 1, 2, 3, 4, 5 different experiments. So it's done at 5 different pHs. There's another 5 experiments. There's another 5 experiments and another 5. So just one of these videos is actually multiple experiments that live inside of it. The students can graph it, can put it in a table and graph it. And there's a lot of really cool features that Pivot has if you haven't looked into Pivot. If you are a college instructor or want to look at something slightly different, because I know plenty of people that use Pivot for college, but there's another offering that we have from a company called 80 Instruments. They have an entire biology course that they've developed. This is different from Pivot in that this actually works with our oxygen gas sensors. So if you actually had a PC computer, you could plug in the oxygen gas sensor that we were just playing with, and you could do this entire activity with it. You could collect data in real time. They also have sample data that's provided. So you could also have students, there is a remote option. This is very feature rich in that it asks you several questions that you try to answer beforehand, or the students try to answer, and then you can check your answer. It'll tell them what's wrong. There's a really nice view of the setup that we just showed you. And then there's even a super nice video that they've put together. So this is a great video showing you basically what I just did, only in a much nicer, professional, really great way that they shot this video. And they used enzyme suspension. They're going to show you how it's used. We're going to put it on a stir station, etc. So it's also a really, really great resource. And then last, let's see, where was the Google Drive? Yeah, I think that's pretty good right there. If you have questions, why don't we take some questions in the last sort of 15 minutes that we have. Feel free to ask me anything, or Sarah. Sarah's actually also she's a PhD biologist, knows a great deal about enzymes as well, and all of our offerings. So feel free to ask questions, and I'll stop there.
We just need a repeat of the lab site for 80 Instruments. Could you maybe give the URL for that?
Yeah, I'll give it that URL for that is, it's actually LT. I'm at the Cura Cloud, but if you search for LT, let me see if we can get to it here. The way that I get to it is if you search for 80 Instruments, hold on. 80 Instruments and LT. There you go. And what's great about it is you can preview it, get a free trial, book a demo, etc. And then here's where you would actually log into it. So I would just go to 80instruments.com/LT. And then you can preview LT or get a free trial. And most importantly, let them know that John and Sarah sent you, since we worked a lot with the folks at ADI on the whole biology curriculum. And I think it's great for college. I also really love Pivot, though. I think Pivot is a great resource. It's incredibly affordable. And since it's in a web-based platform, it works on everything. It just doesn't support real-time data collection, but the videos are amazing. Other questions? Any other questions? I mean, I'd be happy to show you how to data share data from the logger profile so you can see what some of them looks like. Or actually, let me just show you this because this will probably be useful.
Yes, we have someone say please.
Okay, I'll show you how to do that. I've also done something kind of special here is when in the inquiry data, I just want to show you this. I've put this PDF in here, which I think, is that the teacher's instructions? No, I can put the teacher's instructions in here as well for you to take a look at. Let me see if I have those. Hold on. Yeah, hold on. Let me drop this in here for you. Now, this set of teacher's instructions doesn't exist anymore. To make the book smaller, we got rid of a lot of the figures. But I think it's really important because it's going to give you all of the help that you would need to get started. I can actually show you how to log in to get access to the new one as well. But what I really like about it is, if you downloaded it, there's some really nice figures that show you the data for each one of these. All right, so let me show you how to data share really quick. I'm going to launch. Let's download concentration Vmax. Let's download this file. I'm going to move that onto my desktop. Great. And then I'm going to launch Logger Pro. And let me open up that file. Experiments, hold on, I just have to go get it. It should be on my desktop. Oh, there we go, okay. Oh, interesting, this is the advanced topic that I have here. So I've actually got data that I've actually analyzed and put in here. These aren't the raw runs, but I also have the raw runs available. But I'll show you how to data share. We'll see if it comes over. This will be a good test. So then I'm going to launch Graphical Analysis and let's do new experiment. There's this selection right here called data sharing. If you select data sharing, since my Mac that I'm using is on the same network, so GA and Logger Pro on the same network, if I select that, oh, there, the data just came right across. So the data appeared. It even has the note on top of it as well. That's up here. It doesn't have these little interpolation calculators, but you can see advanced topic, estimating Vmax. So the title came across, and all of the data is right here. It's really that easy. It's a super cool feature that's in Logger Pro and GA. This is one of the reasons why we thought LabQuest 2 would be so popular, is because with the LabQuest 2, you can also do the same thing. You can send data from one device to many Chromebooks or lots of things. So I could actually do a fit here, apply curve fit. No, I want to do power. There we go. And I could refit that, but that's how you data share. Let's see, did I have another question here? Where is the Google folder that I keep referring to? So there was a Google folder that you have access to, as you logged into, that you should have access to. But there's two of them. So right here,
attached to the chat channel, there should be a link in the chat channel.
In the chat channel, there is a Google Drive folder up here that you should have access to. But also the experiment drive folder that I'm looking at that you can manipulate to or get to, that is also kind of in a Google Drive folder. But the one that I'm referring to is the one that you have access to that's been shared with, let me go back there. There you go, biology workshops, enzyme action real time. So you should be in this folder. And if you can't get access to this or have questions, like I said, you can just email biology@vernier.com, and Angie and Sarah and I will take care of it. We'll figure out where to put it. We'll be able to get the data to you. Other questions? How to use these tools for making videos for students to see later. How to use it for making, that's a really good question. Gosh, it's almost like someone knows what I've been doing. So you mean like this? So I went and I shot like all, hold on, let me turn the,
3.
so effectively this is me on my iPhone shooting the same experiment that I just did with you. So like I filmed each one. I just did the first run. I didn't do all 3, but it's super easy to film, and then you could pass this out to students and say, here's a video of how the experiment's done. I have this for how the basic experiment is done. I also have it for how I did it for temperature, and then I also have it for pH, where I did it for in 3 different pHs, where I showed how it would be done. Does that answer your question for like how we would use these resources with video? And I think that's a really good question. Because for me, I really feel for all of you that are teaching right now. I mean, I taught for quite a while, but I've never had to deal with anything this challenging, ever. Even just doing what I'm doing at home, not being teaching, is challenging in this environment. So having to quickly modify and change as quickly as you have had to is amazing. And that's why we've tried to put together all of these resources for you to use them. It's because as a former teacher, it's really hard for me to imagine changing as quickly as everyone has to this format. But there are so many people that have been amazing and creative. I think that if I was in the classroom right now for this activity, what I would probably wind up doing is flipping my classroom, like doing something like telling all the students, watch the video, and then let's take a look at the data. Or in another way, I might even do the experiment. I might have everybody there and I'd say, well, I'm gonna do the experiment, let's all watch it together. And then ask questions as we do the experiment, which is something that you normally couldn't do because each student would be doing it. But you could do the experiment, have them analyze it, ask questions, etc. But it's just heart goes out to you, and standing ovation to everybody that's teaching right now, because I know, or I don't know, but it's just got to be really, really hard. Other questions?
We had a mention that the question might have been referring to something like Camtasia. I'm not familiar with Camtasia. John, I don't know if you are.
Oh, yeah. So I used to use Camtasia a long time ago. What I have found is that there are 2 resources on PC and on Mac that actually are actually free. So iMovie is actually really good for this. Like, if all that you want to do is record video, edit it, shrink it down, do some basic features, iMovie is free, and you can open everything up in QuickTime and edit it in iMovie. There's a similar editing program that is actually, sorry, I'll talk to you over here. There's a similar editing program that's in Windows. I've started using Adobe, I think it's Adobe Photoshop or Adobe Elements, and that's around $100. But it allows you to do lots of other cool things like put in text, put in transitions. But I'm pretty sure you can do a lot of that in iMovie. I just didn't have time to really go into that. So it was like, oh, well, this looks like it's going to be a little bit simpler to use. But there's a lot of great tutorials for how to use iMovie and actually how to use a similar platform as well. Other questions? Oh, the other thing I wanted to say is this entire activity can be done with a gas pressure sensor, the whole thing. And Sarah and I and Colleen, who work at Vernier, the biologist, we tell a lot of biology teachers all the time, the best sensor to buy first off to use is the gas pressure sensor, because you can use it for enzymes, you can use it for get a grip, and you can use it for transpiration. It's just a really good all-around sensor that does lots of things. And it's really, not that expensive. The oxygen gas sensor is great for this enzyme activity, And there's a bunch of human physiology activities that it's great for as well. And then you can also show, you know, oxygen decreasing in cellular respiration, and also oxygen evolving if you're looking at photosynthesis, if you use all the right preparation. So it's also a really good sensor as well.
Not seeing any more questions. Certainly, if anybody has questions, you can absolutely contact us by email.
We'll be doing,
Vernier.com.
yeah, we'll be doing more of these. I mean, we've just got started doing these. We're going to try to do more. I think next week we're going to be looking at osmosis, and then also a really cool activity where we look at membrane damage, which shows a really cool color change. But like I said, if there's other activities or things you would like us to go over, or you have feedback, once again, email biology@vernier.com and just say, you know, what I would really like to see, or my real big questions are this. Don't worry, none of us are going to be offended by any of the things that you would say. We're here to help teachers. I like to say Vernier is by and for teachers, and we really want to help you. So if there's anything else that we can do to improve on, or things that you would like to see, like, let us know.
And we did have a question in chat about will a recording be available? We are recording this session now, and we do plan to make it available. I don't know all of the details on that. I don't know if Angie has details.
Yeah, and like I said, someone just said here, they're thrilled with Pivot. Pivot is a great resource that's incredibly affordable for high school, and they have put up so much content. I mean, just 6 months ago, there was not that much biology content. They have put together so much amazing biology content over the summer. It's really, really good to take a look at. I mean, they have a lot of great things that are there. It's really amazing to just see so many companies moving so fast to provide resources for teachers. And with that, I think that's all. Yeah, and I think Pivot, I mean, Pivot would be great for college as well. Community college, 4-year, really any of these formats would be great. It just, if there's Pivot and ADI's LT platform, they just cost. So there's a certain fee that you have to pay for them. Whereas the sample data library, this video and other resources we're giving away for free. All right.
Thank you everyone for joining us. And I did answer a question about a certificate of attendance, and we will be emailing those out to you. So you can look for that. And then we will have the recording on our website soon after it is available today. Hope to see you next time. Bye.
Thanks, everybody.
Thank you. Take care. Good luck. Stay safe.